Newton invented calculus. Leibniz invented calculus. That's what you learned in school. But what if both of them were wrong? What if an Indian mathematician solved it 1,200 years earlier? In 4999 CE, an Indian mathematician named Aryabhata created the mathematical foundations of calculus. He solved differential equations. He developed algorithms. He calculated pi to 5 decimals. Europe spent centuries rediscovering what he already knew. Aryabhata was born in 476 CE in ancient India, a mathematician and astronomer from Kerala's Kusumapura school. At 23 years old, he wrote the Aryabhatiya, a text that would reshape mathematics forever. But he was solving something bigger. His problem: how do planets move? Why does the moon change its path? How can you predict these celestial events? These aren't just observation questions, they require mathematics. They require understanding rates of change. Aryabhata realized something revolutionary: break time into infinitely small pieces. So small they're nearly zero, but not quite. If you understand motion during these infinitely small moments, you understand all motion. This is calculus at its core. He expressed this mathematically in what we now call a differential equation. In modern notation, dx, the rate at which y changes with respect to x. Aryabhata formulated this concept in 499 CE. For over 1,000 years, this would remain unknown to Europe. To solve these astronomical problems, Aryabhata created the first accurate sine table. He divided a circle into 24 equal parts and calculated sine values for each angle. This wasn't just trigonometry, it was applied calculus, using differences between values to understand change. His method used something called finite differences, taking sine of angle x, then angle x plus a small amount, then comparing them. The differences between consecutive values revealed patterns. This is calculus applied to trigonometry. Modern computers still use this technique. Aryabhata calculated pi, 62832 divided by 2000 equals 3.916. The actual value is 3.44159, accurate to 5 decimal places, using geometric methods, inscribed and circumscribed polygons. This is applied calculus, showing how mathematics solves real problems. Beyond pi, Aryabhata developed precise algorithms for square and cube roots. His iterative approach, refining calculations to approach true values, remains fundamental to modern numerical analysis and computer science. Aryabhata revolutionized mathematics by naming the first 10 decimal places and using 0 as a placeholder. This innovation, once considered impossible, enabled the decimal system. His foundational work provided the language for modern mathematics, including calculus, to exist. Aryabhata's work didn't end with him. 5 centuries later, mathematician Madhava elaborated on his differential equations. He refined the concepts, he extended the applications, he ensured the knowledge survived and evolved. This was the beginning of a mathematical lineage. In the 12th century, Bhaskara II built directly on Aryabhata's foundation. He developed concepts of maxima and minima, where a curve reaches highest or lowest points. This requires calculating derivatives, understanding rates of change, pure calculus centuries before Newton. Bhaskara II discovered what Europe would later call Rolle's theorem, a fundamental principle in calculus. If a curve starts and ends at the same height, there must be a point where the slope is 0. This is essential to modern calculus. He discovered it 500 years before Rolle. By the 14th century, Kerala mathematicians like Madhava and Jyeshtadeva transformed Aryabhata's foundation into early calculus. They developed infinite series for trigonometric functions and wrote the Jyeshtadeva, considered the first calculus textbook, solving problems Newton would later tackle. The Kerala mathematicians derived infinite series expansions for trigonometric and circular functions. They understood convergence, how series approach true values. They had complete integral calculus. By 1500 CE, Kerala possessed a full calculus system 2 centuries before Europe. Jyeshtadeva wrote the Yuktibhasa, arguably the first calculus textbook containing proofs and derivations of calculus principles. Written in the regional language Malayalam rather than elite Sanskrit, it democratized advanced math, making the complete teaching of calculus accessible. In the 16th century, everything changed. Portuguese traders arrived at Kerala seeking spices and trade. They needed navigation calculations. They needed calendar reforms. They found Indian mathematicians with sophisticated solutions. A knowledge exchange began that history would later deny. Jesuit missionaries came to Kerala seeking converts and knowledge, acquiring Sanskrit and Malayalam manuscripts on calculus. As Professor C.K. Raju's research shows, they extensively studied Indian mathematics, translating and transmitting it westward, likely influencing European developments. In the 1660s, Newton developed fluxions, establishing modern calculus. While his brilliance is undeniable, historians now question his independence. Evidence suggests he may have been influenced by earlier Indian methods, possibly transmitted through Jesuit intermediaries. In 1670s, Leibniz developed calculus, introducing the modern integral symbol. While a genuine innovator, the suspicious timeline raises questions. Whether Leibniz knew of Indian methods through intermediaries remains an open historical mystery. Look at the timeline: Aryabhata 4999 CE, Bhaskara II 1100 CE, Kerala School 1500 CE, European contact 1580 CE, Newton 1687 CE, Leibniz 1696 CE. The mathematics was solved, documented and available, then discovered again. The evidence is remarkable and historically suspicious. Every bridge engineered today uses calculus derived from Aryabhata's principles. Every satellite GPS system runs on calculus. Physics equations describing the universe use calculus. Modern medicine, computer graphics, weather prediction, all calculus. All tracing routes to 499 CE India. Here's the core difference. Aryabhata invented calculus to solve real problems. He acknowledged approximations were practical tools. Europeans wanted absolute truth and eternal perfection. Both valid, both brilliant. But history credited the philosophical approach while erasing the practical genius. It's time we recognized Aryabhata as the inventor of calculus, not as a footnote or precursor, but as the mathematician who solved it. Professor C.K. Raju spent decades documenting this erasure. The evidence is undeniable. History got it wrong. Science requires we correct it. Like and subscribe for more forgotten mathematic history refused to credit. Share this with a calculus teacher. Question everything. Check sources. Remember, humanity's greatest achievements come from cultures we're taught to overlook. See you next time.